High on the Tibetan Plateau, China is planning to build what could become the world's most powerful hydropower dam on the Yarlung River. This project is expected to exceed the scale and output of the Three Gorges Dam. The river, known as the Brahmaputra Downstream, supports hundreds of millions of people in India and Bangladesh. The selected site, the Great Bend, is notable for its significant elevation drop of about 2,000 meters, which provides substantial hydropower potential. Chinese state media reports a possible capacity of up to 60 gigawatts, which is approximately 3 times that of the Three Gorges Dam. The project is a key part of China's strategy to achieve carbon neutrality by 2060, though it presents several challenges. The area is seismically active, which raises important safety considerations for such a large structure. The Tibetan Plateau, sometimes called the Third Pole, contains a sensitive ecosystem that could be affected by large-scale construction. Downstream countries are concerned that changes to the river's flow could impact agriculture and local economies. There is currently no formal water-sharing agreement between China, India, and Bangladesh, leading to uncertainty for downstream communities. The dam represents both a significant infrastructure project and an example of China's expanding regional influence. Decisions regarding this project are likely to have effects beyond China's borders. The project highlights the intersection of engineering, environmental management, and international relations. The outcomes of this development will be closely observed by many stakeholders. The Yarlung is the world's highest major river, originating from the Yangtze Glacier. It follows a path across Tibet, moving through varied and challenging terrain. As it passes through the Great Bend, the river forms the world's deepest canyon, which presents significant hydropower potential. This region is a tectonic plate collision zone, making it susceptible to earthquakes. The steep canyon walls and remote high-altitude location create logistical challenges for construction. The area experiences extreme cold, thin air, and a limited building season, which require advanced engineering solutions. The river's flow varies due to glacial melt and monsoon rains, and it carries significant sediment that can accumulate in reservoirs. Managing sediment is a key technical consideration for any dam project here. The Yarlung supports a unique ecosystem, including rare fish and wildlife adapted to the high plateau environment. A dam would affect fish migration, change water temperatures, and modify the flow of nutrients downstream. These changes have environmental and social implications for communities that rely on the river. Decisions regarding the river have the potential to impact millions of people. The river presents both opportunities and challenges. Utilizing its hydropower resources involves significant trade-offs. Chinese engineers are planning a large dam in the Great Bend of the Yarlung River. The project may involve diverting the river through extensive underground tunnels to increase energy generation. This approach would result in new records for dam size and tunnel length, representing a significant engineering challenge. China's previous experience with large-scale dams, such as the Three Gorges and Mekong Cascade, provides relevant expertise, though the Yarlung project is unique in its scale and location. Constructing tunnels through the Himalayan rock will require advanced technology and careful risk management. The dam will need to be built to withstand seismic activity, using specialized materials and construction techniques. Delivering electricity from this remote area to China's industrial centers will require a new network of ultra-high voltage transmission lines. The project involves more than constructing a dam. It represents a significant step in engineering development. Each phase will assess the capabilities of China's engineering and technology sectors. The outcome may influence future global standards in dam construction. International observers are monitoring the project's progress with interest. The dam is projected to generate up to 60 gigawatts of clean energy, which is nearly 3 times the output of the Three Gorges Dam. It is positioned as a key element in China's strategy to reduce coal consumption and achieve its climate objectives. The project is also described as a driver for economic development, providing employment opportunities and infrastructure improvements in Tibet. Supporters highlight benefits such as reliable power supply, enhanced national grid stability, and progress toward carbon neutrality. However, the financial investment is significant, exceeding $160 billion, with potential for cost overruns. Environmental organizations note that hydropower development can impact local ecosystems and biodiversity. Actual energy production may be affected by seasonal river flow variations, sediment accumulation, and climate change. The overall outcome will depend on how these technical and environmental challenges are addressed. The project has the potential to contribute to climate goals, but also raises concerns that require careful consideration. Discussions about the project's merits and drawbacks are ongoing. The Yarlung Dam serves purposes beyond electricity generation. It is considered a strategic asset for China. By developing domestic hydropower, Beijing seeks to decrease dependence on foreign energy sources and enhance national security. Constructing the dam in Tibet also reinforces central government presence in the region, supporting economic and political integration. The dam provides China with a degree of influence over downstream countries, including India and Bangladesh, through its management of a significant water resource. This approach can affect the regional distribution of water resources. Completing this complex dam project demonstrates China's engineering capabilities and technological development. The dam is also viewed as a source of national pride. It can serve as an instrument in China's foreign relations. The project is intended to enhance both influence and energy capacity. Its significance extends beyond electricity production. The primary concerns associated with the dam are seismic activity and environmental impact. Located in a region with significant seismic risk, a reservoir of this scale has the potential to influence local earthquake activity. In the event of a dam failure, downstream areas could experience substantial impacts, affecting large populations. The construction process will result in the loss of forests and habitats in an area known for its biodiversity. The dam is expected to impede fish migration and alter the river's natural flow, which may affect local wildlife and communities. Relocation of Tibetan and minority populations is likely, leading to changes in settlement patterns and cultural landscapes. Downstream, sediment retention could reduce the supply to the Brahmaputra Delta, potentially increasing erosion and impacting agriculture in Bangladesh. Changes to the river's flood cycles may influence farming and fisheries that depend on seasonal patterns. The environmental and social effects of the project may be long-lasting. The overall consequences of the project require careful consideration. China's large-scale dams provide important case studies for future projects. The Three Gorges Dam has produced significant electricity, but also led to the relocation of over 1 million people and contributed to environmental changes such as pollution, landslides, and ecological shifts. Downstream, reduced sediment has impacted agriculture and fisheries. On the Mekong, China's upstream dams have changed water flows, resulting in drought conditions and challenges for millions of people in Southeast Asia. Limited information sharing and unilateral decisions have led to concerns among neighboring countries. The Yarlung project may encounter similar issues, especially given the region's environmental sensitivity. Downstream countries are monitoring developments closely, aware of the potential for repeated challenges. Previous experiences highlight the importance of careful planning and cooperation. News of the superdam has raised concerns in India and Bangladesh, both of which rely on the Brahmaputra for water, agriculture, and daily life. India is apprehensive that the dam could influence water flow during periods of drought or flood. In response, India is considering its own dam upstream, which could contribute to increased competition in a sensitive region. Bangladesh, located at the river's end, is particularly dependent on consistent water and sediment flow for its delta and agriculture. Any significant change in river conditions could affect soil quality, land stability, and food production. For Bangladesh, maintaining river health is essential for community well-being. The effects of the dam extend across national boundaries. The river remains a vital resource for millions living downstream. The Yarlung Dam has become a significant factor in Asian geopolitics. In the absence of binding water treaties, downstream nations depend on China's cooperation, which remains uncertain. There are increasing requests for transparency, data sharing, and regional collaboration. Establishing a joint river commission could encourage trust and reduce the risk of disputes, provided China participates constructively. This project presents an opportunity for China to demonstrate leadership through cooperation and responsible management. The decisions made will influence not only energy production, but also the stability of the region. International observers are monitoring how China approaches the management of its major river systems. The future of water resources in Asia may be shaped by the choices made in the coming years.